Hello, this is or are sections 5.7 and 5.8, and we're really going to focus more on 5.7. And we are applying real world problems with exponential functions. Now for the EQ, I would like you to write your own financial word problem about yourself. Take out a loan for a car, for college, deposit money, invest it in something, or put it in a savings account or checking account. So have fun with it. All right. So financial models, these are important because sometime in your life you will either borrow money, taking out a loan, right? Whether that's to buy a car, a motorcycle, to start your own business, to go to college, you borrow money. Now, when we borrow money, there's something called interest. So when you're borrowing money from a bank, because they're allowing you to do so, you have to pay them back the amount you borrowed plus a little bit more. And that is going to be the percentage of the interest rate. Also, credit cards do this too, because you're actually borrowing money from them to pay for whatever you are buying, whether it's a pack of gum or a car. Investing, you're putting in money to a bank or something or some financial institution. And for them, they're saying, oh, thank you. Thank you for letting us take your money. And we're going to give you a certain percentage, also an interest rate. And we're going to take that and give you a little bit extra to come and be at our bank. So we have loans and investing. So investing is like a savings account at a bank, a checking account. There's something called a money market account. There's a money market. There's sometimes called a CD, certificate of deposit. There's lots of different things. If you have a bank, go talk to someone and ask them the different things. You can look online. That's probably safer right now. Look online and see the different things investing they have. All right. Some of the vocabulary you have to understand is called compounding. And compounding is powerful when you are investing money and even borrowing. You need to understand what they're doing and how they're doing money. So annually compounding means once a year. Right? Semi-annually is twice a year. Quarterly means 4 times a year. Monthly is 12 times a year, and daily is 365. And you're going to need to know these numbers when talking about compounding. So the more compounding, the more money you get, or you have to pay back. So if you're borrowing money, we want compounding less. If you're investing money, we want compounding more. So that means every day, so daily means every day they're going to give you a little bit more. So say you get 2 cents extra. So say that you invested $50, and then in one day you get 2 cents. And the next day, you're now making money on $50.02. So then maybe you'll get 3 cents, and then you add up a little bit more and a little bit more. As opposed to monthly, you only do that once a month. So that's a big difference. All right, there's some formulas you're going to need to know and some variables that go with it. And this is terminology you need to know when you're talking about money. The principal is the money that you start with, whether it's the money you borrowed or the money you invested. It's the principal, starting value. R is the interest rate. It will give it to you in percent, and then you have to be able to convert it to a decimal. So if it's 5%, it's 0.05. If it is 6.5%, it is 0.065. So you're moving the decimal 2 places to the left. Year, the time is in years unless it states otherwise, but it's in years. Number of times compounded per year, and we talked about what those words means: quarterly, monthly. And A is the total amount, total. So that is the amount you borrowed and interest, money you borrowed or invested plus the interest. So the interest is already rolled into that formula. Okay, so I have my textbook here. When you do these problems, you're going to need a calculator and you're going to need your notes because you're going to need this formula. Okay, so what this formula looks a little complicated. So the one's always standard. The R is going to be your interest rate over the number of compounding. And you're going to do order of operations. You're going to do this. You're going to add everything inside first. It'll give you a decimal. Then you're going to use the power button and you're going to multiply it, or so take it to that power, n times t. So you've multiplied n times t. Then after you do all this, then you multiply it by the principal. All right, so I use my sons as examples. So Mrs. Mendoza's number 2 son borrowed $2,000 at 6.5% interest for 3 years compounded monthly to pay for college. After the 3 years, what is the total amount he must repay? How much is interest? All right, so when you read it, remember all those variables. We're going to identify the variables and which number goes to which variable. So I have P, it's my principal. How much did he borrow or invest? So he borrowed, right? So it's going to be 2,000. That's my principal. And then you have the interest rate, your R. Remember, that's the percent, and we have to change it to decimal. So it's 0.65 years. That's going to be in time, T. And it's a compounded monthly, and that's N. So monthly is 12. So we're going to do that formula. So make sure you're looking at it. So it's principal times 1 plus the interest rate, decimals, 0.065 over R. No, sorry, over N. That was R. N, which is 12. And it is N times T. So N times T is 3 times 12, so that's going to be 36. So you're going to put that in your calculator. So okay. So I'm just going to show you something so you know if you're on the right track. So you do all this first. So you'll have 1.005461. It has a bunch of numbers that way, right? So you're going to take this and you're going to do the 36 power. And then you're going to multiply it by 2,000. So it had one about, and you don't have to do this every time, but I'm just going to show you just to make sure you're multiplying right. So you can check with that. All right, so the amount he has to pay back is $2,429. And because it's money, we're going to round to a penny, 2 decimals. Right? All right, so you can see that he started with $2,000, but there's this extra amount that he has to pay. That is the interest. So what is the total amount? That's my total amount, $2,429.34. the interest then, right? We have to subtract the $2,000. So the interest is $429.34. Okay, so that's borrowing. You have to pay extra back. Now there's another type of compounding, and it's compounding continuously. It's very close to daily, but just a teeny bit more. And when you're doing it for an extended amount of time, that teeny bit more will add up. So this is slightly different. So A equals PE to the RT. So we can see that E we had talked about 2.718, I believe. And this is being multiplied. Just note this is multiplied, and then this is the power. In order of operations, remember, power comes first. So really, you want to do this part first. I'm going to put the parentheses in. Okay. All right, so the variable, the same. They represent the same thing. P is still the principal, the amount that you either borrowed or invested. R is the interest rate in decimal. T is still the time in years. And A is the amount you will have in T years. All right, Miss Mendoza's number one son won $10,000 on a scratcher. Lucky him. He decided to take half of the money and put it into a money market account. If he invests the money at a rate of 4.25%, compounded continuously, how much money will he have in 5 years? All right, so remember, we're going to start by taking the numbers and putting them with the correct variable. So I'm starting with P, and that's the principal. So it's not $10,000. We said half. So he's doing half of the money. So half of that is 5,000. Okay, and he invests the money at a rate of that. So that's R, and it says rate. So forget, change it. 0.425. Yes, you have to keep all those decimals. Compound continuously. Now, the moment you see that, that tells me, okay, formula A equals PE to the RT. I know, it spells PERT. Okay. So there's no N. I'm going to say that again. There's no N because we now have E. And then we need T, and so that's for 5 years. Okay, so A equals P, so that's 5,000. I'm going to put that E to the RT. I'm going to put 5 times. All right, so when you have that, and you're like E, you should have a button in E. On my calculator, it is above ln, or natural log. Okay, and just again, this is just checking. I would never do this on paper, but just so you know, if you're on the right track, you should have something like this in your calculator. Okay. Again, do the parentheses first. Okay. So you can see how much money he's made. Now, it's not asking for the interest, but we can see he started with 500, but now he's made over $1,000 in the 5 years. All right. Number 3, son. Now this is different. This says that's finding the principal. So he wants to have $4,000 by the time he graduates. Well, that's nice. He's planning. From high school in 6 years. All right, so we have this and that. How much principal, so it's looking for P. Does he need to invest at a 13? Oh, this is high. This is not even close to what we had. Now, interest rate compounded daily. Okay, so daily, that's 365. All right, so I don't know the principal, okay, because that's what I'm looking for. My time is 6 years. My interest rate is 0.135. You're like, whoa, wait, so this is how you get it. So it's 13.5, right? That half can be just written like that. Oh, but this is how they write it sometimes at banks and things. So just so you get used to that. And then N is 365. Okay. So this test, but where does that go? That goes A. That's the amount he wants at the end. So 4,000 equals P times 1 plus R 0.135 over 365 times NT. So N is 365 times 6 years. Okay. So class, this time I'm just going to do this whole thing in my calculator. So I have parentheses 1 plus divided by 365 times 6. All right. So that whole thing turned out to be approximately, okay, I'm not writing the whole thing down, but I'm not rounding. I'm just showing it so you have, oops, 7 something. So now what I'm going to do, I'm going to take this and divide it by that. Okay, I think I did that right. Okay. So now you're going to divide this to both sides. All right. And my answer is the principal needs to be $1,779, and it's a 69.8, so I'm going to round it up to 70. This is 69.6987, which rounds up for me to be 70 cents. Yeah, because that interest rate is beautiful. All right. So that's working backwards. All right, so that was financial models. Now, exponential growth and decay. Very similar. This is actually the same as PE to the RT, just the variables are different. Instead of P, we now have, it's called N naught. It's not N to the 0. It is to the 0 in that it's the initial, it's beginning. We call it naught, as an NAUGHT. So it's the original amount or initial. Initial always means beginning, starting place. The N of T is the final amount, and you can see our variable is T, time. K, which is a constant, and we sometimes have to find K. Hopefully they give you what K is. If K is positive, it's exponential growth because it's going to be a positive exponent power. If K is negative, less than 0, then it's decay, because then that is negative, and T is time. And this time it doesn't, you can see it's not in years. T can be in different days, months, weeks, depending on what we're talking about. So when we're talking about growth, We talk about populations. We talk about bacteria growing. This is something that you may have learned in chemistry. For decay, we talk about carbon dating or half-lives, that the amount of material is decreasing over time. And again, we have the E. All right, this looks complicated. It's a lot. There are a couple problems like this in the textbook, but if we just take it apart, it's not that complicated because they give you the formula. And it's just interpreting this formula and what it means. Okay, so let's take a look and read it. A colony of bacteria that grows according to the law of uninhibited growth. Uninhibited means that just grows on forever. There's no predators. And it just will grow and grow and grow if it just left to its own devices. Right? Is modeled by the function n of t equals 100 e to the 0.045 t, where n is measured in grams, so tiny, and t is measured in days. All right, so this is done, and this is all right. So I'm going to write over here the formula, right, so we can compare things. All right, so we know that the number in front of E is the beginning. So determine the initial amount of bacteria. So that is the number in front of E. So have E here, what's in front? 100. All right, so that's our initial. And what is the growth rate of bacteria? Well, the growth rate was K, right? So my K up here, it's positive, so it's no, it's a growth, and that's my growth rate. It's 0.05. Now, if you're doing it at a percent, we're moving the decimal in the opposite direction. So it would be 4.5%. What is the population after 5 days? Okay, now, so A and B was just looking at the equation and understanding the parts. Now I'm actually have to find things. Okay. So here it says 5 days. Now we talked T is in days. So T equals 5. So I'm just going to substitute that in. So n of 5, right? Function notation. So you're just substituting. Times 5. And remember, you have to do this part first in your calculator. Okay, so I have 100 times E. For me, I needed a second button. And it will really, what you type in really depends on your calculator, or if you're using a phone. So you have to really get used to that. So it's 1.25. Does it say how to round? No. Okay, now what are we doing? In grams? It's measured in grams. So in grams, weight, I'm going to go here, round that. Grams. Now if it was people, you can't have a percentage of a person, so I wouldn't do that differently. It would round here instead. All right, but this is grams, and I can have fraction of weight. How long will it take for the population to reach 140 grams? Okay, so that would be your final, and that would be over here. So that's where I'm going to put that. So it's 140, and now you're looking for time, how long? So my initial doesn't change. My K doesn't change, but now we want to know this here, T. Okay. So you're going to be like, all right, Miss Mendoza. Now, class, you have to keep this here. So you're going to have to divide by 100 first. So before we deal with T, you have to get rid of this here. So I'm going to divide 140 by 100. Gives a nice decimal of 1.4. Okay. I'm going to run out of room. Because of this class, and hopefully you can always rewind, I am going to erase this. Because I'm going to need that space. All right, so when you have this, you can see, oh, I have T up there, but I don't want T up there. How do I bring T down? Ooh, down. Oh, it's a power. Haha, power down. So what I need to do, the inverse of an E, so you have to do the inverse, right? The opposite of the opposite operation, which is inverse of E is natural log. So I'm going to take the natural log of both sides, right? And I'm going to power down, and this is going to come in front. So I'm going to have a natural log of 1.4. Or we also know that this will just go to 1, right? This will undo, and then you are just left with that. So either way, you will have that. And then you can see you're just going to divide out 0.05, 0.045, take my calculator, and say natural log 1.4 divided by 0.045, sorry. And it is 7.47, 4 decimals every time, days. And we're going to have a fraction of a day because it can be hours and minutes and seconds. All right, and that is D. Whew. We're still not done. I have E. Okay, so I'm going to erase this on the bottom so I can have space. And I'm going to read, what is the doubling time for the population? All right, and do you remember how much we started with? 100. So what would my doubling be? Well, double would be 200. So it's just like D, but instead of 140 grams, we want to know how long it will take for 200. So it's going to be the same process. So I'm dividing 100 to both sides, and you get this. You're going to take the natural log. Oops, sorry, I divided that wrong. Divided 100 is not, 200 divided by 100 is not 200. It is 2. All right, so we are going to take the natural log of both sides. It's like squaring both sides. You're taking the square root. The inverse of E is natural log. This will undo. Or you can power down and then undo. Either way. Then we're going to divide, right, to both sides. Natural log 2. All right, and my time is about approximately 15.4033 days. All right, exponential growth. All right, half-life. These are a little bit more complicated. The half-life of radioactivity of isotope is 5 days. If 8 kilograms are present now, how much will be present after 12 days? Okay. So remember that our formula is this. Okay, they give us time. They give us 2 times. Okay. And a half-life is here. What they don't give us, and they give us an initial, this is my initial, right? It's present now. But what they don't talk about is K. So you have to find K. Ugh. Okay. So you're going to find K because you can't do it until you find that constant. And you're going to use this first sentence to find K. right, so the half-life means this. Whatever amount I start with, and I'm going to call it X. I'm going to call it X. What I start with, X. Right? The half-life will be half of X. Right? So I start with 50 grams. The half of it would be 25 grams. If I had 100, it would be 50. So it always is half of X. We're going to look for K, and that T is in 5 days. That's very fast. So I'm going to divide X to both sides, and then it goes away. So now I just have half. And we can change half to 0.5. That might be a little bit easier to calculate. And I'm going to write 5K. Now, just like before, we're going to take the natural log to both sides. This will undo that. The natural log, and I'm going to put 0.5 because that looks better. That looks like multiply. 5K. Sorry. And then you're going to divide 5 to both sides. All right, so K is approximately negative 0.1386. And you're like, Miss Mendoza, it's negative. Yes, because it's decay. Remember how we said if it's decay, K needs to be negative. So that's perfect. All right, so now we're going to use the second sentence. If K, so this is going to be your initial or starting amount. And we're going to do 12 days as your time. So it should be a little bit. All right, so so we're doing an N of 12. Starting with 8, we E. I know what the K is. Negative 0.1386 times 12. Okay, let's see what we get. Okay, and I have 1.5163 kilograms. And there you are. And that's your answer. So these problems, just take your time, really read the problem, and then read it again. Write down your variables, right? And what they represent, and what number they go with. All right, so these two are practice on your own. Yes, they're very similar. I want you to compare between interest rates and compounding and see what you think. Which one do you think would be more? One, the interest rate is smaller, but then the other compounding is more frequent. Okay, and then answer the EQ. Thank you for watching. Bye.